I'm sure I'll get a note on the left if you can't. I'm going to jump straight in just to, and you might have seen a flash of it earlier when I was just checking to make sure it worked. So quickly, who am I? I'm the technical director for EMEA for TigerGraph. I have a very long career, because I'm old, in financial services, manufacturing and retail. Particularly, I worked for Toyota for many years, JP Morgan, anyway, a bunch of people. And now I work for TigerGraph, and the reason I work for TigerGraph is because it solves problems. And I've heard a lot of talk about getting to the value for the business and making sure that that connection to the value is maintained. And I could not possibly agree more. It's absolutely essential. And I'm hoping that I can tell you a little bit of a story about how we solved a problem for Jaguar Land Rover, and also to show how that same solution is actually quite useful in other places. And now I am spearheading its use across all operational areas. So the slide that you can see is really part of the story, is that initially Jaguar Land Rover had a problem whereby they couldn't, if there was a problem with their supply chain, if the supplier didn't supply a part in time to their factories, or indeed if they changed what they wanted to build in the factories, it generally took around 2 weeks to change their planning so that they could make their manufacturing work, which was okay when you could anticipate events, but when you can't anticipate events, that becomes a bit of a problem. And the fact is that in the real world, we generally don't anticipate problems. Problems tend to, the things that hurt us are the things that happen very, very quickly. And in our first iteration, as part of the POC, we proved that we could give them the information they needed in about 15 minutes. And then it took them about 25 to 30 minutes to build the PowerPoint deck that they could run up to the executive suite to say, we need to change all this. There's a big risk. We need you to sign it off. So that was the 2 weeks to 45 minutes story. And that's very well covered in a number of recordings. Please visit our site. You'll be able to find the JLR use case very well described there. What I want to talk to you about today is how I looked at that and I went 45 minutes. That's still 45 minutes. And when we are talking moving analytics from the reporting, the very slow batch idea, and we're trying to move it into the real-time use cases, into the real situation where time is literally money, then I wanted to get into the real time. And that's exactly what I'm going to talk about today. So just a quick, because I'm obliged to, cover of what TigerGraph is. It's way more than what I'm going to talk about today. It's a distributed analytic graph database. What does that mean? It means that we can handle very large data sets. Being a graph database, we are very good at modeling connected systems of data, which pretty much all of them are, really. I think almost everything that we care about in operations is connected, like a connected network of data, and that's what we do very well. We have very advanced analytics which we apply, and that's really because the language inside the engine you can write the analytics directly. So in one place you can actually create these graph analytics, and then with the data you get from that, you can then feed it into your existing artificial intelligence, machine learning, or whatever existing systems you've already got, essentially to enhance them, to improve them. This is why we talk about in database machine learning. And the way it's in database is, first of all, we can feed your batch processes to get the machine learning, the training done. You might use Data Robot. It's a fantastic tool for that. But at the end of it, you're going to have a model, and you need to be able to run that model. And there's two situations there. One, you'll either need to be able to supply it with the data that you trained it with. And again, a graph database you've supplied it from the graph database in the first place, so it's very good for that. And it's very, very fast. We do streaming of data. We have no pauses. We can handle enormous data sets at enormous speed. And I'll give an idea of what those numbers are in a minute. And that essentially allows you to run real-time your machine learning in the real-time situation, which is what we're talking about. You want to be able to run your models in real time so you can use them on the ground at the times you need them. And in manufacturing particularly, but in retail as well, this is essential. Otherwise, what's the point? If it's not real time, then there's no point in really doing it. It's then just a strategic tool. And we're trying to get it into this tactical space. We also, for the very highest performance requirements, actually can import the models directly into the database. We have some people who are managing large electrical systems with that, and by that I mean national scale electrical supply systems. We also have people doing the fraud analytics in real time using our database at banks and things like that. So we have a lot of experience in the real-time use cases, as well as the more traditional, more batch BI use cases. On here, you can see a number of people. Again, I don't want to spend too long just doing the sell. I want to talk about the story a little bit. So the way I simplify what we are in this space is why TigerGraph instead of any of our competitors, or indeed any of the other technologies that are out there, is we have three things. I think of us as being the first 3 out of 3 graph database. The three things are that we can handle big data. We've got some systems running, again, with these real-time analytics, particularly in the fraud space, with 30 terabytes of live data running. It's an in-memory database. So that's 30 terabytes of memory, continuously running streaming data, continuously updating the database, and continuously scoring the updates as they come in. And this is used for things like working out whether a telephone call is from a fraudster or whether it's from somebody you care about. It's very fast. For the telephone system, we have a requirement that we respond in 10 milliseconds. So it's that kind of speed. Again, being in-memory database helps there. Although we are transactional to disk, so you're not sacrificing anything for that in-memory capability. We're also fast in terms of processing. We have a massively parallel processing system. What that means is that we can take one query and we can divide it across every CPU in your entire cluster. And that allows us to be able to do real-time analytics, which is a bit of a holy grail, is to be able to do the kind of scoring and analytics that you want, albeit on a restricted data set, but to still maintain this sub-second response times. And finally, the smarts we're putting in here is, because it's a new technology and people are not necessarily familiar with it, we want it to be as accessible as possible. We don't want to make it hard for people to use this. This is another new thing. We've already got this gigantic stack of technologies that we're having to deal with already. It's not reasonable to ask a business to take on yet another technology unless we can have an accessible, easy route in where they can get the value very quickly. And so we can steadily build confidence that it's worth investing more time and more effort into this way of working, so with the new technology. So here's the problem statement. So getting into the requirement. First of all, when something goes wrong, what do you do? This is the operations manager's nightmare, which is pretty much a daily occurrence, particularly in any complex system, is things always going wrong. Now, the problem with a very large scale system, and we proved this out in a number of places, but JLR are a large car manufacturer in the UK. They sell a lot of cars. You'll notice that in Hollywood movies, all the bad guys drive a Land Rover, or a Range Rover. That's Jaguar Land Rover. They sell, I think it's around about at least 60,000 to 120,000 cars per year. These are very high value cars. They're very heavily customized. And they're expanding very heavily into the electric car market right now. So it's a continuous change for them. So when you're an operations manager and something goes wrong, what you need to know straight away is, who cares about this? Is this something that I need to ring the boss about, or is this something that I can ignore? There are lights going off all the time. We've got millions of things happening all the time in a manufacturing system. It's very unlikely that you're going to have green lights across the board. So the question is, first thing you want to do is prioritize for me all of the things that are currently broken, and there will probably be a list of 100. Which ones do I need to care about straight away? And the best way of doing that is, who is affected? How big is the problem? Just because one thing has said there is a problem doesn't mean that there isn't going to be a much bigger problem. You often have cascading failures. It may be that you've only got one sensor or one customer who is complaining. And it may be that you've got a lot of customers who actually are affected by this. You just haven't heard from them yet. And what you want to do is get ahead. You want to be able to deal with that quickly. You want to identify them quickly and at least be able to ring them up so they've got a chance of actually dealing with the problem as it occurs until you can fix it. You want to know what caused the problem. You want to know who you should call to get it fixed and also to warn people that there is an issue that needs to be fixed. Later, once things are starting to calm down, then you want to find out what the root cause is. Just because a problem occurred in one place doesn't mean that that was what caused the problem. It was maybe further upstream in your process. In fact, it almost always is. But at that point, you want to prevent it in future. So root cause becomes something that you really care about. And given that you have this giant list of problems, you've got this giant list of root causes, so things are happening all the time, from an executive point of view, you need to work out which one do I want to invest in? Which one's got the highest risk? Which one's got the highest cost of failure? Which one am I likely to be able to solve the most quickly? In other words, to get the benefit as quickly as possible. So from an operations point of view, if you could answer these questions every time something went wrong, and you could answer them really quickly, you've probably cut a massive percentage of time out of, in terms of the load on the operations staff who are trying to do this, allowing you to scale your teams much better. And the other thing is, people will like you better if you ring them first when something goes wrong, and sometimes you can fix it before they even notice it goes wrong. So that's the key point, is to be able to react and act extremely quickly in a confident way without, while staying within budget. It's this is always the key problem for any operational system, is you can't, this is a cost to your bottom line. So you need to be able to do this very efficiently. So, solution. In manufacturing world, we talk a lot about digital twins. The digital twin is really just a model of your operation. But because your operation is a network of interacting components, you really need to create a network model. And the first thing I can say about graph databases is they explicitly model networks. And so you're immediately in a very good place. You're not having to translate it to a relational or a different model. You can stick with the model you've got. This gives you a lot of advantages. For starters, it's really quick. It's very easy to model. It makes sense to the domain owners. They can immediately look at it and recognize it and say, oh yeah, that seems to have all the pieces I care about in it, which is very important to get buy-in in the first place. And also it's incredibly efficient when you're actually processing across it, because I'm not translating backwards and forwards between questions which are aimed at the network model and the real representation of how it's implemented. If you're going to do it properly, you need to track everything. So in a manufacturing system, track all the parts, all the things that are happening. You need to track all of the events, so all of the success or failure events as they're passing through the system. And you need to maintain a history of that, because it may be that you find out something went wrong a long time after it happened. And so particularly in cars, if something breaks when somebody's driving it down the road, then because a part has failed, you want to know why that happened quite a long time after the event. Empowering humans in the loop is important. These are very complex situations. It's not reasonable to expect to automate these operations. So really, what's better is if you assist the humans to be able to do their jobs better. This assistance of human beings is really where I think is the next step for all AI and ML. I think there has been a lot of focus on automation. I think that's a very low-level set of use cases, very valuable and essential, but I think to get to the next level in terms of complexity and scalability, you should be looking at how do we empower people? How do we make their lives better? How do we make it so that they are better at their jobs and they're happier in their jobs because they're able to, that sense of power, that sense of agency is the key to getting happy, productive people. Your information systems then need to be comprehensive, complete, and accessible. That implies big. So your big data needs to be joined together, or graph databases join things together. So we're in a good place again if we're going to look at a graph solution. And the other thing is, in a very large network, things are changing all the time. It's not static. A single model is no good. You need to have to be able to dynamically augment and change your model as time goes on. And that is something that needs to be part of the system. In other words, you have now got a data ops problem, this problem of how do we deal with change in the system, be it developments in the real world or developments internally, and to be able to use them. Here's some important factors to bear in mind, particularly for large enterprises, and this is pretty much true of most enterprises. System downtime for a factory, one factory, is about $1 million a day, or €1 million a day, and that's a gross oversimplification. I know we have people in the steel industry who may say to me that's actually a very small number, and actually our downtime cost is much bigger than that. But clearly it's a big number, and even in the retail space, we've had similar comments that as much as those numbers might be spread out, if you look across the operation, this is the core of your business. If you cannot operate, you have no business. And so whoever you are and whatever that number is, then this is important. And what the emphasis is that time is everything and seconds count. And so the idea that you could stop a factory for 2 weeks is just insane. And so as a result, they were spending a vast amount of money to avoid that downtime. When you can react more quickly, you can perhaps focus your resources a little bit better, and therefore effectively reduce the amount of money you're essentially paying for insurance against these problems by focusing where you invest in that. Millions of events a day operating on billions of parts, big data. You need it to be big. Fast isn't good enough, it has to be big. And because it's joined up, you can't split it into lots of little pieces. It needs to be one big piece, all linked together in order to get the benefit. You can't anticipate external factors when they fail, like suppliers failing to supply. You can't anticipate internal issues when they happen, because otherwise you wouldn't have done them. You'd have avoided them in the first place. So the point is, this has to be reactive. There's not an awful lot. You cannot be continuously proactive in this space. And finally, the network model is complex as a result, interdependent. Everything depends on everything else, upstream and downstream in your flows, and dynamic. It's changing all the time. So any solution you have has to be able to take account of those factors. And so it's a hard problem, and nobody's really solved the problem. But what I'm suggesting is that if you take the approach we've taken, is one very good way of addressing all these factors, and it's the thing we think about a lot. Applicability. This isn't just about manufacturing. It's supply chains in manufacturing, it's manufacturing processes, it's warranty for when things broke in the car, as I mentioned earlier. It's data pipeline operations. We've got a retail customer who actually is applying this to all of their data pipelines, and they say they have millions of data transfer jobs a day, but if some of them go wrong, some of them are incredibly important. And so, for example, their tills will stop working in their shops. You can't sell anything if your tills stop working. And so they're down completely across the entire organization. But similarly, it could be restocking reports. It could be any report where you need to be sure that the number on the report is actually valid and up to date. So there are financial implications just from data quality. And so as a result of that, they're using exactly the same idea of how do I manage my data operations on a day-to-day basis with exactly the same solution in mind. And so we can reapply the same solution into a slightly different space. Schema management, they want it to, that was the change to the network. They want to be able to change their reports and know which reports are likely to break. They want data lineage. They need to understand, when I get a number on a report, where did this number come from? How quickly can I work out where the source of any information? Supply chain forecasting. Where do I focus my investment in order to improve my supply chain? Where am I going to get the best bang for the buck from my limited budget to ensure that I don't have these problems? Supply chain ESG assurance, what does that mean? There's a big focus in regulation right now on making sure that your suppliers are actually following the rules. So there's the Modern Slavery Act in Europe. The US is just involved, has brought in a number of regulations to say which countries you are allowed to receive goods from and how those goods need to be certified. So being able to track every part allows you to literally say that from this bag of coffee or whatever is your product, I can tell which farm it was picked on, where it was processed, what were the results of any tests you've done on it for things like heavy metals and things like that to make sure that it's of the appropriate quality. Having that at a very fine-grained level means that an assurance activity that would normally be extremely painful and often done one-off now can be done extremely fine-grained and very, very efficiently. This applies to everything. Again, steelworks, quality. You need to be able to know that you've got quality up and down the chain, that everything is exactly to the specification, because that's what they care about. So you need to produce a huge pile of paper. It's the same with logistics, with fuel, with the applications are endless here. Network risk assessment, really this comes back to forecasting, which is, can I simulate a failure and work out what that means to me? And in our systems, what we do is, because you've got a perfect model, we literally break everything one by one in the model, not in the real world. And then we cost up, how much would this cost if this failed? And that allows you to essentially heat map your entire enterprise from moment to moment and give you an idea of exactly where my risk really lies. And so therefore, where perhaps I should focus my efforts on remediation. Just to give you an idea of what a car model looks like, and to say, why didn't they just use what they had? They were on Google Cloud, BigQuery. They absolutely could afford to run the best of the best in this situation. But this is what their model looked like. In order to run a query, one query for one car, this is a 36-way join. And for even one car, it would take hours to return. And we're talking about doing it for 60,000 cars. So it's an incredibly complex model that you need to deal with, because our enterprise systems are in fact complicated networks. And so it makes sense. But what this does is really say why the problem of modeling things, translating them into a relational database actually creates a problem for you. Whereas the only way you can make this work is by having a very, very direct approach to this. And as I say, they were using BigQuery, the biggest setups they could possibly get, and they couldn't get answers to the questions. This is the one that we took and we remodeled directly, and we did it in 25 minutes. Demo, let me show you something real. So this is what it's going to look like this is what we are currently developing. This, what you can see before you, is in fact a live proof of concept, which we are building on top of. And the first thing I want you to notice is it's completely in real time. This is taking data from the database extremely rapidly. And what it can always do immediately is show when things happen upstream. So we're starting to answer our questions straight away. When is there a problem? Well, do I deal with this problem? And here we can see, this one's okay, but we see that there is actually a problem upstream here. That's this is called a problem for this guy. And so the first thing we want to know is who else do we need to call? So I can immediately click on it. I can click on the downstream. I'll try and zoom it in a bit so you can see what's going on here. And so you can see that this report, so this little car on the right, has had a problem here. And what we will immediately need to do is say who else might be affected. You've just got your call list. That's less than a second. In fact, immediately you can get this. And immediately they can look at those and go, okay, that customer is not a problem. He's not expecting it for a week. That customer, he's already should have had it. He just hasn't called us yet. So, you know, this is often the situation. And it gives you a chance, immediately your operator's in a position to be able to ring the right people, mobilize the right people to actually fix the problem, which is occurring here, and get on with it. So I've basically covered the first three questions immediately. The next question is, okay, root cause analysis. How are we going to deal with this? What was the real root cause here? Again, if we click on here and we look upstream to where things might have gone wrong, if I can get it to click for me, yes. Here we can see that actually there was a change event that occurred here. I'm sad to say it seems to have been in TigerGraph schema, but there you go. The change event was here. And so the question is, what am I going to do about this? And so immediately we go, right, how much do I need to invest in this? Is this an important part of my chain or not? What we can do is we can click on this and you can see that actually this is an important part of my chain of activity. And so therefore it is worth this much to invest in improving this, in making sure that this doesn't happen again in the future. And so effectively in a matter of seconds, we are answering all of the questions that people want for one problem. That was just for one problem. So if you've got 20 problems on your list, that means in a matter of minutes, you will be able to prioritize immediately who you need to call, when you need to call them, and how you need to prioritize resources to basically get them fixed, and also to feed upwards to the root cause analysis and the remediation activities that occur on a more global and strategic scale. And that's the kind of speed that we're looking to give people, both in the tactical case, but also using exactly the same model for the strategic case. And you'll notice that none of this involves writing any code. This is a simple use case that, even though it's extremely difficult to actually process this amount of data at this speed under the covers, the outputs are actually extremely understandable. And therefore, you should be able to give this to the business. And if they value it, they'll look at that and they'll say, yes, it's a simple yes. They don't need to necessarily know the detail. They don't necessarily care about the detail. But what they do care about is, can show me that the value is actually tangible. And that is exactly what this is intended to do. I'm kind of going to stop there just to see if there's any questions, if that's all right.
Thanks a lot for this incredible presentation, which was expected. So, Ricard, well done. Thanks a lot. There are a lot of questions, definitely. Just to be a little bit, I give information about the program of the day, and then we come back to the questions. So in 5 minutes, we have lunch time, so people can go anywhere they want. Back in 1 hour on board again. So please come back in 1 hour for the rest of the event. It's more interesting, even arranged for afternoon. But now I want just to ask the people who want to get engaged with the questions that we can give them microphone and headphones. So to feel free, there is no need to rush. Anybody who wants to continue, we are here that 1 hour to serve you with TigerGraph, help me with the questions. Now, question is here, Ricard, if you look at the question from Sami, we go from the last one on the chat area, Sami Ahmaahu, I don't know from which company. Fully agree, Richard, that this was a problem for a graph solution, but at the same time, I would say that a 36-way join would be an anti-pattern in BQ in any case. I don't understand the question properly, but
yeah, you think, but sometimes it gets that way. I think often we tend to isolate our view of the world into these little silos. We talk about siloed data a lot, but particularly when you're talking about an enterprise operational operation, it actually crosses all of those silos. So you're kind of stuck with it. You can't simply look at procurement, can't just look at suppliers and not worry too much about where it's supplying to and what happens about it. And particularly the reason I bring in the operational case is because that ultimately has to cover goods coming through the door, being in the right place, being of the right quality, being of the right type. I mean, the JLR case, something arrived and it was just broken. They just literally couldn't build the cars they intended to build that day. And so very rapidly, they had to say, well, what else could I build with the parts I have? And that's a really complicated and difficult question, because it implies you need to know, what are people wanting to buy soon? What sort of cars are they? What are those cars made out of? Do we have the parts to make them? Do we have suppliers who can get the stuff to us? You see what I mean? Essentially, it runs all the way from the chain, from end back to the beginning. And so you're kind of forced into this situation where you have to deal with joining together an enormous amount of data very, very rapidly in order to answer the questions. And typically in the past, people have kind of taken individual queries from individual silos and put them into Excel spreadsheets, or and then worked to try and join the data together. It all becomes a little bit clumsy. Whereas what I'm suggesting is, in the operational use cases, there is the possibility to actually just cut through that, not worry about it, and actually get useful answers very, very quickly.
Thanks a lot. But now to one of my hero participants who asks a lot of questions from Scania. Gustav, you are co-host. You can switch on camera and mic to be clear with the question. Okay, the microphone on as well, please. Thanks.
Hey, Gustav.
Yeah, Gustav, can you? Gustav is here with 2 accounts, so I give co-host in the other one as well. Yeah.
Yeah, go for it.
Yeah, hi. Yeah, I was interested. You talked about models.
Yes.
Can I get my video working as well? Yeah. Hi. So what kind of models are that? Are these deep learning models you're referring to?
No, these are essentially physical models of the world. This is your digital twin. So the idea is that you create a digital representation of what is in the real world. And so what that means is that your entities are things like machines, they are suppliers, they are cars. It's very traditional entity modeling, actually. It's almost more traditional than relational. In relational, we start off with this entity model and then we normalize it to make it work with relational databases. This is pre-normalization. This is literally thing connected to thing and how it's connected together. So it's a much more basic view of the world.
Okay, so you have the graph database, that's one thing, and then you have a model that you evaluate against.
So once you've got the model and you've got the data in there, then you've got the basis which you can use for scoring, for evaluation. And indeed, we do a lot of foundational data work towards deep learning models, for example, and things like that, because we provide a lot more data and context. And if there's one thing that machine learning models love is context. The bigger the context, the more chance there is, the more information they have in order to come up with interesting observations, find interesting patterns in your data. And so that's a very key use case for us, is providing that very rich data set towards AI and ML models.
You talked also about streaming data. What kind of streaming is that in technical terms?
Primarily, it's events. They come over messaging layers. And when I say events, in manufacturing, you talk about sensors and digital twin world, but really it's just these are things like, my part has arrived, part number 36 has arrived from the supplier, as a simple event, and that's a success, great. Or the guy goes to the bin to get some parts and says, my part has not arrived from the supplier, which is obviously when you get a red light and now you want to actually work out what's going on. But similarly, it could be customer rang up with a complaint. It could be report didn't run. It could be, it's all these very real world events. And so they arrive over messaging bus is usually. I can show you a picture of.
What kind of platform are you running on?
We run on a cloud platform mostly, but we do on-prem as well. But right now, we do a lot of partnering with clouds. We are partnered with all of them, AWS, Azure, GCP. And we provide database as a service so that you don't have to worry about managing it if you don't want to. You can simply consume it in the same way as you would normal cloud services. Or if you have an on-prem setup, then we're very happy to support that as well.
Sorry, Gustav, can you unmute it again?
No.
Yes, thanks.
Okay. Yeah, it sounds like you've done something really interesting, and I fully understand the idea of having the data in the graph database. That's and that it's fast. I think what's hard to grasp in your presentation is actually how you use that, how you go from having the data to create the value.
Yes. So one thing is, one way we do this is from what I originally showed, which is that small application. But in a generic sense, and I can show you a big fat technical diagram if you like. In fact, I will, just for fun. Let me see, because I, of course, have one prepared. So if we look at technically what's going on and the way that it embeds, and this is a conceptual architecture, effectively what we do is, first of all, we worry about where do we get our data from, and for that we can either retrieve data directly. We have things like we have adapters for data warehouses, for example, or for data services, which generally brings in bulk data in batch. And we also have standard interfaces for messaging infrastructures. These are all imported directly into TigerGraph. Because TigerGraph is an online data, does online processing of data. While you write data, there's no indexing process required. You can immediately use it as soon as it has landed in the database. We expose the data via very standard interfaces. We have standard interfaces for your BI tools, which you would expect. So things like Tableau and things like that, if you have those, and indeed operational dashboards, which would normally expect log files, we can produce those as well. Or for the more real-time pieces, we expose standard web interfaces, RESTful APIs. And the great thing about RESTful APIs is that everybody already talks RESTful APIs. So all of your data science, all of your Python, all of your deep learning, everything that you have right now, all of your platforms, they will be able to consume this directly. And what you do is you write your queries in TigerGraph and they automatically expose these APIs. And that kind of allows us to fit into it without having to disturb any of your existing architecture. Well, that's the idea anyway.
Like the use case that I see on this chart is that you use this as a database and you do traditional analytics by making queries and produce dashboards, and you can create training data sets by making queries.
Yes, absolutely. And we can split the graph into different places so that it's very easy to get a subset of the data, because not everybody cares about all of the data all of the time. So it's quite easy to separate that, either for security reasons or just to make it easy for people to.
if you map your root cause analysis problem to this, what parts of this are you using then?
Root cause analysis, the simple point is what I showed on the UI was where you simply need to find all of the steps in the process associated with a particular problem. So that's the first piece, is where do I find my data? Once that gives you your starting point. At that point, there are further analytical queries that take a bit longer. They're not necessarily real time anymore, but they're still usually within 10 seconds, which will give you all of the information you can around those elements, all of those elements in that chain. So that's the first part. And then really what you want is people want to be able to navigate through the data. Sometimes they will, if there's a machine broken, they'll go to the machine and actually look at what's broken, and you'll start creating investigations. And actually we use the techniques that we're applying there are actually very similar to what are used in anti-money laundering investigations and things like that. It's almost the same idea. And really the idea there is that you need a tool where people can navigate through the data, again, without having to write queries. They just want to be able to get hold of the data and turn it over and look at it and understand what's going on. And so we have user interfaces that look a little bit similar to the one I showed you. And we use, we're a database company, not an application building company. So, but if I show you, we have a whole bunch of different charts, timelines, maps. There's loads of different pieces we do to try and allow you to get a lot of value without having to dig too deep into the guts of the system.
I see the map. Do you have geospatial support in particular?
We do, yes. We have basic geospatial support. We tend to add in libraries if we need them. A lot of geospatial stuff is on the user interface side, but we can do things like tell you distances. We can do things like find areas. Are you within an area outside a polygon, that sort of thing. So the simple stuff we do. Once you start getting into a complex world, people that will tend to live in the application layer, and then we just make sure we can feed the data fast enough to make it useful.
Thanks a lot for your answers.
Not at all. Thank you.
We have other questions, Richard. Everybody has the option of switching on camera and mic now during this Q&A time, so you can ask now. Eugene?
Yeah, thank you. Hello, Richard. I've recognized in your solution a lot of similarities from the material tracing application that we built. So I have actually two questions. The first question is more related to the use case in automotive industry. I know that in the automotive, very often you could have kind of rush orders that are a bit unexpected, unpredicted, and they can affect your supply chain and bring chaos into the whole. So I'm wondering if you could maybe forecast, maybe calculate the probability of such rush orders in the whole supply chain.
Whether they happen at all is obviously, as you say, it's a rush order. You don't know. I think there's two ways in which we help. One in the forecasting is if somebody says, do you know what? And this is a real situation, was where they forecast about 5 years ahead in the car industry, because of course they have to literally build factories to build the cars. So their forecasting is very long term. It's always wrong. So when it comes to the year-on-year forecast of what they're actually going to build, then that forecasting, yes, we can help with that. Again, it comes down to really about whether, if they change their forecasting, whether they can whether they can get the parts from the supplier to build it, because often they have guaranteed to buy a certain number of parts, and if they change, then that can change their contractual obligations a little bit. So they need to know the effect of that. So that's the medium-term problem. The short-term problem is, the cars I am building, can I give them to somebody else? How's that going to hurt me? What can I do about that? And again, we can provide exactly the information about, if you take these types of cars and you adjust them slightly so they're actually more suitable for somebody else, in order to, what are you going to sacrifice in order to satisfy a rush order? It can, and this actually takes quite a long time because it's a very complicated question, a simulation. We will simulate that and tell them, okay, this is probably your least cost, or whatever your global objective is, possibility to do this. And And that allows them to essentially choose what their, gives the executives the information they need so they can get, okay, we'll give that guy a discount in order to take a 2-week delay, and that way we can get this guy in for the front one. You know, that's the sort of conversations they want to have, but they don't want to guess. They want to be able to see the numbers in front of them so that actually they can justify it, so that when the customer they're sacrificing a little bit rings up and says, what are you doing to me? This is a terrible situation. You know, they're already armed and they said, look, we know we didn't want to, you know, it's not a situation we're pleased with, and this is what we're going to try and do to make it up to you. So that informing those conversations is really where we help, by giving them a very clear analysis of which change is the most appropriate or the most likely to satisfy their objectives, and what's it going to cost? What are their alternatives? What different paths have they got? Okay,
makes sense. And another question is more a technical one. I understood that you are using the graph database as a core. And in case of the root cause analysis, very often you need to deep into your data and to see, for example, the deviations on of your process parameters when it comes to the sensor data. So this relation between your material or your piece, lot, whatever, and this sensor data is required. I'm wondering how you store this process data, sensor data, IoT data. I'm not sure that it is then possible to do in the graph or with the graph databases.
You're absolutely right. There is a limit. We are memory based, and eventually you're in the world of petabytes where that's not going to work, or you're dealing with data that's just not appropriate. Like it could be a picture of something, or it could be a scan of a document. There may be unstructured data. You know, there's all sorts of things. So we kind of push towards a slightly more modern, kind of more of a microservice architecture. And so the idea is that in the applications themselves, they would then decorate we would provide the pointers to what they need to look at, and then they would usually pull that from their main data warehouse platforms, because that's what data warehouses are for. And this is why we are starting to get very closely integrated with things like Snowflake, for example, and things like that. And ultimately, in the way people usually do it in the current architectures, in microservice style architectures, is you always have this middle tier that's gluing together all these other pieces of data. And we try very hard to support that. Again, the REST APIs technically make that quite an easy integration for most people. And people are often using data integration platforms for this. And that's great for us.
Okay, thanks a lot.
Thanks a lot, Richard. I know you're hungry, but I'm just waiting for 2-3 guys to ask questions if they have. So I just asked Apura from GSK UK if he has a question, or Igor from Liebherr, Germany, or Jon from Danske Bank. Any questions, guys?
Hey, not from my end, Musin, at the moment. Thanks very much.
No problem at all. My pleasure. Happy to have you with us. Anyhow, the other colleagues from TigerGraph are going to be with us in the afternoon. Now we have just 14 minutes for lunchtime. So I leave you in peace. Thank you so much, Richard, for the presentation. Have a lovely day. We are here, but you can just leave and come back at 2 o'clock. It means in 45 minutes, please. Thanks a lot.
Okay, thank you.